In lesson 5.4, how can I solve special systems of linear equations? Here we have, if you have to graph each y equal mx plus b, start with the y-intercept, use the slope to move up, down, left, or right. Finally, we have here three special cases. How? If you have here two intersecting lines, it means that I have exactly one solution. This point, the intersection point between the two lines, is my solution. Okay, so if you have two intersecting lines at exactly one point, my point is my solution. One solution. Okay, from where I know that I'll have two intersecting lines if I have different slopes. So you have a given system of linear equations. Put each one in y equal mx plus b. The first equation, y equal mx plus b. The second equation, y equal mx plus b. And compare between your slopes. If you have different slopes, so you have exactly one solution. This one is called consistent and independent. If you have here same slope and the same y-intercept, if you have y equal mx plus b, compare between the slopes and y-intercept. If you have same slope and the same y-intercept, like for example y equal 3x plus 5, and the second one y equal 3x plus 5, so you have same slope and the same y-intercept, it means that I have same line. Can you see here? Actually, I have here two lines above each other. Here, same line, just one line. Here I have infinitely many solutions, and this one is called consistent and dependent. Okay? If you have same slope but different y-intercept, same slope, if you compare between the slopes and you have same slope but different y-intercepts, means we have two parallel lines. And in that case, we have no solution. When you have two parallel lines, means no solution. This one is called inconsistent. So you should study this part in lesson 5.4. Okay? Let's start with lesson 5.5. Here, first, before lesson 5.5, I put here, let's solve an example. X here, divide by 2 to keep y alone. I divide here by 2 to keep y alone. So y equal 1/2 x plus, when you divide 2 by 2, it will be plus 1. And the second one, keep y alone, move negative 1/2 x to the other side, it will be positive 1/2 x. Compare, can you see? Same slope and same y-intercept. If you have same slope and the same y-intercept, it means that you have infinitely many solutions, and this called consistent and dependent. In B, distribution, multiply 2 times x is 2x and 2 times 1 is negative 2 here. The second one given in slope-intercept form, y equal x plus 1. We have here different slopes. So if you have different slopes, so you have two intersecting lines at exactly one point. You have only one solution, and this one is called consistent and independent. So you have inconsistent, or consistent and independent, or consistent and dependent. Okay, in lesson 5.5, how can I graph a linear inequality? First, you should put y. You should solve your inequality only for y. Okay, y like an equation, like y equal mx plus b. Solve your inequality and keep y alone. Then, how can I graph? As usual, start with the y-intercept. And use the slope to move up, down, left, right. Okay, how many steps up, how many steps to right, how many steps down, how many steps to left. Then, if you have the equal sign, you should draw a solid line. You should draw a solid line. If you haven't the equal sign, you should draw, here I have in the equal sign, you should draw a dashed line, okay? If you have greater than or equal to, we will shade above the line. If you have less than or equal to, we will shade below the line. Here is a way to graph a linear inequality. Like here, I kept y alone, move positive 3x to the other side, it will be negative 3x, then divide by 2 to keep y alone. Divide by 2 to keep y alone. So y more or equal negative 3 over 2x plus 3. How can I graph? Start with y-intercept, start with number 3, and use the slope. The slope here is negative. So you can move 3 steps down because the negative sign, 3 steps down and 2 to right. So from number 3, I'll move 3 down and 2 to right. 3 down and 2 to right. Form your line. Okay, you have the equal sign. So you will draw a solid line. If there is no equal sign, you should draw a dashed line. Okay, it's more than, so we should shade above the line. Here is my solution. Any point here is my solution. If it's out here like 0 and 0, if you try 0 and 0, it can't be a solution of your linear inequality. Like here, to check your answer, he used 0 and 0, he got a wrong statement, so it can't be a solution. If you choose a point from here, it will be right, so it can be a solution. Okay, lesson 5-6, same way to graph. Y here alone, just you have to keep y alone in the form of y equal mx plus b. Okay, then graph. As usual, start with y-intercept, use the slope to move up, down, left or right. If you have the equal sign, you will draw a solid line. If you haven't it, you will draw a dashed line. More than, shade above the line, less than, shade below the line. Okay, if you got two parallel lines like that, okay, can you see here, this my solution, this area my solution here, and for that line here my solution. I haven't any intersecting area between the two lines, so the system here has no solution. Okay, if here this area, my solutions are here. For example, I shade here below the line, the blue one, and for the red one I shade above the line. So here's my area, this one, here is my solutions. Solutions are all points between the two parallel lines and on the solid line, okay? Okay, if here I have here is my line, my blue line, for y less or equal negative 3x minus 2, the first linear inequality. Okay, all of this one my solutions for the first line. For the second line, y less or equal negative 3x plus 4. Here, my area here, my solution here. So where is my solutions here? Will be for the first line. Can you see? Because the red line is included. The red line here is included. So here, this area for the first line, for y less than or equal negative 3x minus 2, I'll find my solutions. Here we make revision on chapter number 5, lessons 4, 5, and 6.